First, let's go over some very important terminology. Firstly, we have simple interest, and the formula is this one right here. And then we have compound interest, and this is the formula. And then we have depreciation. Now, there are two types of depreciation. We have linear or straight line or reducing balance. So whenever they talk about straight line depreciation, this is the formula that you go for. And whenever they talk about reducing balance, this is the formula that you go for. And then, so what is the A, P, I, and N stand for? A is the accumulated amount. This is the money, for example, that after 5 years that you take out of the bank. P is the principal amount. This is the money that you put into the bank. I is the interest rate, and they give you the interest rate as a percentage, and you have to convert it into a decimal. And then N is the number of payments, and I will show you how to determine N. So a question might say 25% compounded monthly. So then you would need to divide the interest rate by 12 and then multiply the number of years by 12. So this is the table that you need to know when it comes to them. If they say compounded quarterly, what do? You divide by 4, and then the number of years you multiply by 4. So here is an example. A car rental company bought a fleet of 15 cars for 3 million. They calculate the depreciation rate at 15% per annum on a reducing balance method. Now they want us to calculate the value of the fleet of cars at the end of 5 years. So this is an example that talks about depreciation. So the formula that we will use for this one is A is equal to P into 1 minus I N. And we want to calculate the value of the cars at the end of 5 years. So we want the value of A. So our principal amount is 3 million. 1 minus, and our interest rate is 15%, and we need to convert that to a decimal, which is 0.15. And remember, it's per annum, so you're going to divide the interest rate by 1, which basically does nothing. And then for how many years? For 5 years. And then you should get an answer of 133,115.94 rands. So let's take a look at another example. So at what percentage interest, so we want to get I, compounded quarterly, should a lump sum be invested in order for it to double in 6 years? So here we are investing money and we are compounding quarterly. So this is the formula that we will use. And in this case, we want this money to double in 6 years. So let's say we invest X amount of money into the bank, and when it doubles, we will take out 2x after the 6 years. So that is 1 plus, and then we want the interest rate. So remember here, we are compounding quarterly, so we divide our interest by 4, and then we multiply our number of years by 4 as well. So now if I go ahead and solve this, I can cancel x on both sides, and here I'm left with 2 is equal to 1 plus I over 4 to the power 24, and then I can take the 24th root on both sides. So this leaves me with this and 1 plus I over 4 on the left hand. So then I can bring the 1 over, so that is minus 1 is equal to I over 4, and then after bringing the 1 over, this whole thing here, I can multiply it by 4. So that would be 24th root of 2 minus 1. That whole thing is multiplied by 4, and that gives me my interest rate, which when you put into your calculator, you should get an answer of I is equal to 0.1172, and then if you convert that into a percentage, it should be 11.72%. So that is the annual interest rate that you should invest your money for it to double in 6 years if it is compounded quarterly. Okay, now let's talk about converting nominal rate to annual effective rate. And the formula for that is the effective interest rate is equal to 1 plus the nominal interest rate over n raised to the exponent n minus 1. Now here, this is the effective interest rate and this is your nominal interest rate. Now the n in both cases will always be the same. This n and this n is the same. So if you are compounding quarterly, then you would n is 4. If you are compounding monthly, n is 12. It will always be the same. So let's take a look at an example. So here is an example. So we have an amount that was invested at a rate of 8.5% compounded quarterly, and we want to calculate the effective interest rate per annum of this investment. So the formula we go for is the effective interest rate is equal to 1 plus the nominal interest rate over n raised to the exponent n minus 1. So we want to calculate the effective interest rate. So here they have given us the nominal interest rate, which is 8.5%, and when we convert that to a decimal, it is 0.085, and we are compounding quarterly, so we divide the interest by 4, and then we multiply. Then the exponent will be 4, and then you have this minus 1, and then if you punch all of that into your calculator, you should get an answer of 0.08774, and when we convert that into a percentage, it gives me 8.77%. So this is something that is very important, whereby you need to be able to convert between the effective interest rate and the nominal interest rate, being able to convert from one to the other. And then we have cases where we talk about deposits and withdrawals. Let's say, for example, I go to the bank and deposit 10,000 rands. And then 2 months after that, I go to the bank again and deposit 2,000 rands. And then 3 months after that, I go to the bank and withdraw 5,000 rands. And then 7 years after the first deposit, I go to the bank and deposit 1,000 rands. And this happens, and this investment is for a duration of, let's say, 12 years. So when you have a case like this, you want to treat each deposit and each withdrawal individually. And I'm going to show you an example of that right now. So here is an example. So we have Amanda who deposits 50,000 into a savings account which pays 11% per annum compounded monthly. She wants to buy a car in 5 years' time. Calculate how much money is available to her in 5 years' time if a further payment of 10,000 was made exactly 2 years after her initial deposit. So in this case, we are going to do a timeline, right? We're going to do a timeline. So the investment, we have T0 up until T5, and this is in years, right? So she deposits 50,000 rands, so we will say plus 50,000 rands, and 2 years later, she deposits 10,000 rands. So at T2, she is going to deposit 10,000 rands. So in this case, we will treat the 50,000 individually. So what we'll do is we'll compound the 50,000 from T0 all the way to T5, and then we'll also compound the 10,000 from T2 all the way to T5. And since these two amounts are deposited into the bank account, they will have a plus sign in front of them, and this is what I mean. So the total amount after 5 years, the total will be equal to the first, that is the accumulated amount. It's the first payment, which is P into 1 plus I N, and then we add that with the 10,000 rand, which is P into 1 plus I to the power N. And now we can do our substitution. So we have the 50,000, that is 1 plus the interest rate is 11%, so that is 0.11 over its monthly. We divide by 12, and now for how many years? So it's 5 years, so it's going to be 5 multiplied by 12. And then we have the 10,000 rands, which is 10,000 rands, 1 plus the interest rate is still the same for the entire 5 years. It hasn't changed. So it is 0.11 over 12. But now we are starting from year 2. So it's going to be year 3, year 4, and year 5. So it's 3 years. So that would be 3 times 12. And then you can punch all of this into your calculator, and then you should get an answer of 100,334.57 rands. So the important thing about these types of problems is that you treat each amount separately. So now let's do another similar example, but we will also have deposits and withdrawals as well. So here Susan made an initial deposit of 28,000 into an investment account. So let's do a timeline. So at T0, she's making a deposit of 28,000. 3 years later, she made another deposit of 12,000. So that's plus 12,000. And then she withdrew 6,500 from the account 5 years after the initial deposit was made. So at T5, she is withdrawing, so negative 6,500. And the interest rate for the first 4 years was 12% compounded monthly. So let's add something. So for the first 4 years, so at T4, so for the first 4 years, we had 12% compounded monthly. Thereafter, the interest rate changed to 12.9% compounded half yearly. So 12.9% half yearly. So the first question is calculate how much Susan had in this investment account 2 years after the initial deposit was made. So she's investing money. So this is the formula we go for. And she invested 28,000 rands. And the interest rate for the 2 years, because we want 2 years after the initial deposit was made, the interest rate was 12% monthly. And for 2 years, so we will say 2 times 12. And then if you punch all of this into your calculator, you should get an answer of 3,552.57 rands. And then the next question is, how much will the investment be worth 8 years? So this money will be there, the savings account will be for 8 years after the initial deposit was made. Remember, we will treat each amount individually. So we'll take the 28,000 and then we'll compound it all the way to T8. And then we'll also take the 12,000 rand, we'll compound it all the way to T8. And then the 6,500 rands that was withdrawn, we'll also compound that all the way to T8. So here, the total accumulated amount will be the first amount plus the 12,000 minus the 6,500 rands. So this is how we will set up our equation. So then now we can do our substitution. So it's 28,000 rands 1 plus. Now this 28,000 rands underwent 2 interest changes. The first one was for the first 4 years, which was 12% compounded monthly. So it would be 0.12 divided by 12 and raised to the exponent for 4 years. So it's 4 times 12. And then bracket. So we took the 28,000 to T4 and now we have to take the 28,000 to T8. So the interest rate over there changed. So we'll say 1 plus 0.129 divided by 2 because it's half yearly, and then we'll say, so from T4 to T8, so it's 4 years multiplied by 2. So now we're done with the 28,000 rands. And then we move on to the 12,000 rands. So it's plus 12,000 1 plus the interest rate at T3 was 12% compounded monthly. And so this 12,000 for 1 year, the interest rate was 12%. So we'll say 1 year multiplied by 12, and then we'll multiply this. We'll say 1 plus, and then the interest rate from T4 to T8 was 12.9% half yearly. So it would be 4 multiplied by 2. And then the last money amount that we will deal with is the 6,500, which was withdrawn. So that's why we say minus 6,500, 1 plus, and then the interest rate from T5 all the way to T8 was 12.9% half yearly. So it's 0.129 over 2, and then that would be for 3 years. So it's 3 multiplied by 2. And then if you punch everything exactly as it is into your calculator, or you can punch each amount separately. Let's do each amount separately. So this all gives me an amount 87267.25. So the important thing when you get these type of problems is that you treat each amount separately, whether it's a deposit, whether it's a withdrawal, and just be mindful if there are also interest changes during the course of that account.